Thank you, I forgot what it's called. Polynomial stuff. And you guys have all graphed quadratics. You guys have all graphed lines. But what we start to do in Algebra 2, especially honors, is that we start to look at more and more of the upper degreed polynomials in such a way that we can graph them without the use of the calculator with pretty good efficiency. And believe it or not, it's relatively easy. What we're going to wind up doing here is we're going to build ourselves out of what's called end behavior. End behavior is nothing more than what is happening at the tails of a graph. Think about think about a quadratic. End, excuse me. Think about a quadratic. Quadratic's either up like a cup or down like a frown. So the tails, when it's up like a cup, what is the leading term coefficient? It's positive. If it's down, what's the leading term coefficient? It's negative. When you have a quadratic, what's the degree? 2. So is that an even or odd number? Even. Okay, keep that in mind here. What's going to happen then is that I want to look at just a couple quick notes. Don't write out this whole nasty definition of polynomial. I just want to show you how the book defines some of these things so you get an idea of when I say leading term coefficient, what exactly that means. When we're dealing with polynomials that are higher degree polynomials, instead of being squares, we're looking at 4th degree, 5th degree, and so on. What we're looking at is it in this what we call a descending order? So it might be 3x to the 4th minus 2x cubed plus 4x minus 1. Isn't that a polynomial? It's just an example. I'm trying to show you little bits of it here. Is that in a descending order?
Yes.
Is it missing anything?
Yes.
What's it missing?
2.
Squared. It's missing that next squared term. Now, this comes in really handy about it's missing an x squared term tomorrow when we start talking about long division, synthetic division, about how we can find zeros really fast. What could I put into that polynomial that wouldn't change anything? If I put in 1 squared, wouldn't it change it? 0 squared. So you don't have to do this for looking at a polynomial, but tomorrow I could put something in here and write plus 0x squared plus the 4x minus 1, and it just continuously brings each power down by 1 at a time. This is a little trick that we'll do more and more tomorrow. Today it doesn't really matter, so we'll bring that back. The degree. The degree of a polynomial is the highest power that's a regular counting number, if you will, above 0. Actually, it could be 0 because then it's just 1, and that's just a horizontal line, which is still a polynomial. But what we're looking at is they're going to be positive values. What's that? Oh, I thought you were saying something. What would be the degree of this one that I put up here? 4. This is the biggest degree. Okay, it's the biggest exponent. Yeah. It's that basic. Okay. So the degree in this case is going to be 4. Now, the degree of a polynomial has a couple of things, and you guys remembered this, well, hopefully you remember this, from quadratics. When you had a quadratic, it was an x squared term. When we used, what was that called, do you remember? The discriminant. What did the discriminant tell you? Solutions or zeros, if you will. So you had 2 solutions, 1 solution, or 2 imaginary solutions. So what happens here is that using things like this, you guys already knew that a quadratic could have up to 2 solutions. It could have 1. It could have none. They could be imaginary. Along those lines. So what we talk about with the zeros, the zeros of the polynomial, that is, if you're looking at your leading terms, coefficients, degree. In other words, what was the example we had? Let me bring this over. Let me just do this. If we keep using this generic polynomial, What was the degree of that? So how many possible zeros do you think you could have? 4. What happens here is that the zeros, you can have up to n degree zeros. Excuse me. Do you have to have 4?
No.
Could you have 2? Yeah. Because what happens a lot of times is that the graph itself might only touch the x-axis once. It could have imaginary roots. We didn't graph those. Okay? You could have up to that many zeros. So if you have a 3rd degree polynomial, how many times could it cross the x-axis? 3 times. Okay? If you have a 5th degree, how many could you have? Yeah. The next one is called turning points. We don't use turning points as much in Algebra 2, but we use them a lot in pre-calc. And knowing that all of you guys are going to be in pre-calc next year, you might as well learn a couple of terms. I know, I'm asking a lot. What do you think turning points mean? This is a tough one. Where it turns. Well, think of it this way. If you have x squared, what does that graph look like? It's a parabola. How many times does it change direction? Once. Remember what an x cubed function looks like? Kinda, yeah. Does this. How many times does it change direction? Twice.
No, because it's only 2 curves.
Yeah. So these turning points are where the graphs change direction. And yes, sir.
So like x to the 100th, the graph changes direction 100 times?
Up
Or
to.
99.
It could change up to
Oh,
that many,
okay.
okay? It doesn't always do that. And I'll show you an example here in a little bit. Yes, ma'am.
So technically, an x cubed graph could only turn once. So how would you know the difference if it was an x squared or an x?
It depends on if you're given, it depends on what you're given, to be honest with you. If you're given 1 real root and 2 imaginary, you could have the x, you could have a cubic that only crosses once. It really depends on the problem. I wouldn't, I mean, you're really thinking it's really, really bad worst case. I don't think that ever happens, to be honest with you, for us, okay? I wouldn't worry about that. You guys always worry too much about what's going to happen that's bad. So what happens in this turning points, you can have up to, oops, n minus 1. Remember, the n is our degree. Changes. Okay? And it works very, very simple. There are times that you can have what happens a lot with like 4th degree polynomial, it'll look just like a parabola because there's imaginary roots that don't show. Okay? And we'll see that today in a little bit. So all of these little bits and pieces of polynomials, the little chunks that we talk about, what are the degrees, what are the possible zeros, what are the turning points, things like that, are going to let us graph them really without a calculator. Because as long as you know what the tails are doing, the middle part is just getting zeros. And to get a 0, all you're doing is factoring. Okay? But we need to come up with a rule about the tails, which means I'm going to use a calculator. What do you want, Shimki?
I'll let you talk and see what
No, what do you got?
No. I was trying to ask what the tails were considered.
Ends.
No, I know, but like, do you mean like the end of the equation, like, do you mean like how wide it is? Or, okay, wait, go. Yeah, but the arrows mean they still go, right?
What direction are they going?
Up,
Okay.
down?
Okay.
That doesn't make sense, but okay.
No, Shimki, watch this. Actually, you can do one of these. top one just because I didn't find your picture fast enough. What I want you to grab your calculator, come up here. Yes. Yes. I love to embarrass you. It's fun. Just wait till I make the dice and I roll dice and your face shows up. It's great. All right.
That's great.
JC, I ran out of board space. You have to do the one back there. That's why you're back there. Shimky, you have the top one. Come on, let's go. Go to your y equals table. Put that function in. I want you to just sketch what it looks like on the board so we can all look at it at the same time. Good question. I found that out third hour. I assume that you guys remembered where the buttons were. On the calculator, if you go to your y equals, if you have to raise it to a different power, if you have to go, let's say it's 2x cubed, 2x carats. The caret button is above the division symbol. Once you get up into the exponent, hit the right key to get you to drop back down, okay? Excuse me. So, once you put those in, draw your graph on the grid. All you're doing is just a rough sketch of what it looks like. All of these are going to fit on a 10 by 10 screen, and we're going to look at each one of them in terms of what's the first term and what's its exponent. Okay? It should fit. Does it not fit?
I don't think my window's set right.
Oh yeah, your windows. Just change your window.
Mr. Murphy.
Negative 10. Do a negative 10. Yeah, all these should fit on a 10 by 10. What's up?
Can I get a close look at Eric's
Wait.
board? Like, can I go up there?
If you must.
I have.
Wait, can I move?
I'm to expose you. Wait,
Yeah, don't do that.
Wait, I can't take a picture of you.
No, no pictures. Eric?
You like that? Yeah, I know.
I gotta read it.
So when he was definitely was looking at it, like, okay.
Yeah.
We were hating the.
Hey, blow it up.
If you like this, you. I was like,
Hey, dude.
yeah.
That's not even that long ago. I know.
JC, you got that one? It's okay. You got the tails on it. All right.
That's an 8th grade.
Look, you bounce. Whee! Whee!
What the?
Woo! All right, anyway. So, Shimky did the first one. The first term was positive, and what about the exponent? Is it an odd or an even exponent? It's is that nervous laughter? Or? Okay. The tails were pointing down and up. First term was positive, exponent was odd. Second one, which way are the tails pointing? Up and then down. Remember, I'm reading these things going from left to right. So my second one has a negative odd exponent. Tails are pointing up, then down. Third one, quadratic. First term's positive, x squared. It is up like a cup. And I think I erased that. Oops, sorry about that. The fourth one, down like a frown, isn't it? First term's negative, squared term, we're pointing downward. It's just funny. Fifth one, first term is positive. Exponent is Even or odd?
Wait, which number?
I'm on number 5.
Oh, yeah.
So which way is it pointing? Down then up.
What does it mean it's odd?
What do you mean?
You're saying it's odd.
I'm talking to the odd or even as far as the exponent is concerned. The leading terms coefficient is exponent. What's the degree? Is
Well, I'm gonna cut you over.
Wait, what?
excuse me, I'm choking on water. What you're looking at it on is every one of these is going to have some exponent. Every one of these is going to have some leading term coefficient. The leading term coefficient and its exponent will always tell you the direction of the tails. You only have 4 possibles. There's only 4 possible things that can happen. You can have first term. Let me write this down. Oh, what do we find? Oh, we found stuff. Your first term has 2 options. It could be positive, or it could be negative. Do you agree? The first term's degree, the leading term, if you will, could be even or odd. And by that, I'm talking about is it a 2 or a 3 or 4 or 5. That's what I'm looking at as far as the even and odds. I'm not worried about even or odd functions. That'll come through. So your first term can be positive with even. First term could be positive with odd. Negative with even. Or negative at least it wasn't a calculator. With odd. So what this is going to tell me is that anytime I see a positive first term with an even exponent, what are my tails always doing? Up. Tails are always up. Should probably put exponent in here so you guys remember that. Okay, put that on there. Man. So positive first term, even exponent, tails are always pointing up. It doesn't matter what's happening in between. We'll figure that out as we go on. Some books, I think the pre-calc book uses like a little squiggly line between the two because there's a whole bunch of stuff. I mean, if you look at what JC did, hers changes direction a couple of times. We had ones that just tailed themselves out. It really depends on the function itself, what's going on in between. We will figure out what's going on in between via factoring and stuff like that. I'm sorry, guys. I don't know what's... Yeah. What about positive with an odd exponent? What are the tails doing? Up and, so you're saying they're going up and down?
Yep.
Or are they going down then up?
Down then down.
Down then up. Because you're reading this going from left to right. So it's positive with an odd exponent means it's doing that. What I want you to do here, think of it in just generic x squared and x cubed. And x squared is going to be your parabola, right? Your x squared is always going to do this, if it's positive. If it's negative, what is it going to do? It's going to go down. Same idea with, if this was x to the 4th, the tails would match it. X to the 20th, tails would match it. All even exponents would match those two. You don't believe me, Shipke?
I don't understand what word you're saying.
What do you got?
I don't get where you're getting this term. What term?
What do you mean by term? Tails?
No, like how do you decipher what term to use?
The first term. If I'm looking at,
We keep talking about.
if I look at this, excuse me. If I look at this, this is written as, sorry, I got cut off here. F of x is 1/2 x squared minus 3x to the 4th minus 7. First thing I'm going to ask you, Shimpi, is it written in a descending order? No. How can I rewrite that in a descending order? So, Shimpi, what's my first term?
That one?
The whole first part is the first term.
Not going by degree.
I'm talking about the first term tells me if it's going to be up like a cup, down like a frown, dancing left, dancing right, things like that. Because now if I look here, what is the leading term coefficient? The leading coefficient equals -3. So is that positive or negative? It's negative. The exponent is x to the 4th, which means, is that a not positive, is that an even or an odd exponent? It's an even exponent. So if I have a negative first term with an even exponent, which direction are my tails going to go? They're both going to go down. The tails are going to point downward. You use that because the leading term is negative and the exponent is even. Yes, ma'am?
So if it's like at the top, you always put the little U thing with the biggest
Yep.
degree, and
Decent.
that's always goes.
Yep, descending order. Everything goes descending order to make this stuff work. And I'm
So this is all for parabola.
for any polynomial. Anything at all.
It's like with the positive I, they go like that or like that.
Well,
That wouldn't be a parabola because they're so small that.
You would still have, if you think about, which one is it? I just did this earlier. I have a problem. If you graph this in your calculator, let me get the other one. Put x squared plus 8, x squared minus 5. Put that in your calculator and graph it. I'll come back to you. Kanka, what do you got?
How come for the first one, when it was positive and even, both of the tails went up, but the other example, not this one, the other example, it was positive and then it went down.
If this one was negative, it went down.
So negative goes down.
Right.
And then positive goes up.
Yeah.
And then even goes up.
Yeah, evens, they're both up or they're both down.
And odd, it's switched.
I'm sorry, I'm so confused. Wait.
Again, let's try again. Just straightforward, no extra parts to it. I'm just using one term at a time. I'm not messing you guys up with adding stuff to it.
So is it both down?
Is the coefficient, is it positive or negative?
Negative.
It's negative. So the coefficient is negative. The exponent
It's down up.
is odd.
Yeah.
So coefficient's negative, exponent is odd. Is it going to be tails up, both of them, tails down, both of them, down then up, or up then down?
Down.
Up then down. This is going to go like this.
Okay.
So your tails, we do this. It's your quote.
So, negative and even go up?
Negative and even. So if you have f of x is -6 and an even exponent.
So that's both going up.
Careful. What would -6x squared do? Go down.
So it's
I want you to go back and remember the idea.
No.
Go back and remember what x squared is. Up like a cup, down like a frown. All evens match the same thing. On tails, not just the curve in the middle, guys. You can have all these different changes in between. Just look at the tails right now. I'm just looking at tails. When you graph y equals x cubed, just plain and simple, If you're going to do that, you'd start with -2, -1, 0, 1, and 2. You cube it, you get -8, -1, 0, 1, and 8. You agree on that? If you plotted that, it would be doing that. Increasing, going from left to right. The tails start pointing down and they end pointing up. Works for anything that has a positive first term, odd exponent. Okay? Let's list this out. In positive to an even. Does that make sense if I do it like that?
Yeah.
Positive to an even? Positive to an even. What are the tails doing? Up, up. Positive to an even, up, up. Positive to an odd, down, up. Okay? Negative, even, down, down. Negative, odd.
So like, I kind of understand what's going on, I just don't like get how you know it's a down up or down down and stuff like that.
It's a generic rule.
Yeah, like why is
This,
why-
no matter what you do, anytime you have a lead, when you have it in a descending, anytime you have it in a descending order, if your first term is positive and it's got an odd exponent, no matter what, the tails, the very ends of the graphs, one's going to be pointing down, the other one's going to be pointing up.
Is there a reason for that or is it just cause?
The reason it works out is because of the, what do they call it? I forgot the actual official name. It is in, oh, what is that called? Of course you asked me what a name is. It's the rule of the ends, what is it? The section? Not the fundamental theorem, it's it's, trust me, it's in here. Leading coefficient test. The leading coefficient test works for all polynomials. And that is just one of those rules. Remember how you guys tested for triples? Same idea. How do you know it always works? Because it's a test. It's a rule that you have to follow. Pythagorean theorem works if the sum of the squares equals the other one. How do you know it works? Because it's been shown over and over. All right. Same idea here. No matter what you have, you get this leading term coefficient test is what it's called. And anytime that you have an odd degree, if the degree is odd and the first term is positive, tail down, tail up. Flip it the other way when it's negative. Yes, sir.
Isn't that because the coefficient matches the square, so the x squared will go exponentially higher low compared to the x, which goes.
You're on the right idea, but think of it, when you square a negative, what do you get?
You get, yeah,
Positive.
but it's the coefficient times the square
Correct.
number. So.
And that's another way to look at it. If you do it that way, if you start out with, oh, my pen here. If you start out with just plain old boring, f of x is -8x squared. How do you know that's going to point downward? Well, when you first learned how to graph, what did you guys use? Points, right? You just pick points. Well, you'd make a table, -2, -1, 0, 1, and 2. Well, order of operations tells you to do what first? Exponents. So if I take -8 times -2 squared, what am I going to do? Well, I square -2, what do you get? 4. What's 4 times -8? -32. If I do that with a positive value, -8 times 2 squared, I still get -32. No matter what, as you graph these things, as you're at excuse me, -2, you're down here. Because of that leading coefficient, it's going to change the direction of whatever exponent it is. If that leading term is negative, it means it's going to be quadrant 3 and 4 for a square term. Same deal if that was to the 4th power. It'd still be down below because you have a negative times a positive. When you have an odd exponent, you have 3 negatives multiplied together, for example. What's a -1 times -1 times -1? 1. So if you have a negative coefficient times a negative value, you're going to get positive. So that's why you're starting up in quadrant 2, working your way down in quadrant 4. It's just order of operations that makes it work. Okay? You start breaking it down. And that's why by using order of operations over and over and over and over and over again, you're able to come up with that leading term coefficient test, which just made everything easier by looking at 4 different scenarios. Tails up, tails down, increasing, decreasing. That's all they work out to do. Bryce, or was you?
It is me, but you don't need it. It was the negative to odd exponent.
Yeah.
I just wanted to see how.
Okay. Oh yeah, I didn't put in. I always does this. Did I still have one more to write out? I think. Yeah. The last one we have is negative to odd. What's negative to odd then?
Up and down.
Up, down. What I want you guys to do tonight, we didn't get into the zero stuff, which is fine. We didn't get into that 3rd hour because we had the drill. What I want to do tonight is just show what directions these are going to go. Okay? All I want you to do is next to this is just sketch the arrows of the direction. Okay? No? We'll do more of the graph stuff tomorrow because in this one here, if you want to get into it, a lot of these things are starting themselves out to be factorable. Come on, guys. A lot of this stuff's going to start out to be factorable. If you want to start factoring some of them, go for it, because you're going to be doing a lot of it over the course of the next few days. Most of them are going to be able to factor pretty fast. Okay? So if I'm looking at this, yeah.
Wait, so are we sketching the graph or only putting the arrows?
We're just putting in arrows. I'm going to put this up here so I can show you guys. Where is my... No. So if I'm looking at the first problem. What way are the tails pointing? Both of them? Up. So in that first one, I'm just going to put this right now. For right now. I look at the 6th one. What way are they pointing? Down and up. We haven't factored something like that, have we? What's your first rule of factoring?
GCF.
What's the GCF here? X. So if I factored out an x, I get x squared minus 4x plus 4. Could I factor that the rest of the way to find my zeros?
Absolutely.
We didn't get to talk a lot about it, but try and factor some of these tonight so we can get it. We can jump start into it tomorrow.
This one.
6. Yeah, if you haven't, I'll worry about the rest of the graph. We'll use the zeros to graph it tomorrow. Well, what time is it positive before you have to get the negative? Negative 2 negatives. Yes, sir. No, because if you multiply all that together, it's still going to be next term. Somebody take it backwards. I think all of these are within these